So in the previous section, 7.2, we introduced the concept of points, lines, rays, planes, and line segments. And today we're going to look specifically at line segments and measuring line segments. Some will be kind of along a number line, so pretty simple to solve, and others will introduce some algebraic expressions. So first, let's just take a look at a real simple example and some notation. Remember, when we talk about a line segment, we'll have something like segment AB with the bar on top to indicate we're talking about a line segment. And if I want to figure out, in this case, how to measure or determine the actual length along this ruler here of segment AB, I could just count. I see it's 1 millimeter, 2 millimeters, 2.5. So that would be pretty simple, but I could also do it using something like this, where I could find the difference of the 2 points. So, eventually we're going to do these on the coordinate plane. So this might be like the x-axis, for example. So if I want to find the difference of those 2 points, I'll subtract them. And when we talk about length, remember when we measure something, it's always going to be a positive number. I'll never have a negative length. So b minus a would be 5.5 minus 3. So the absolute value of 2.5. So the length was 2.5. So I counted 1, 2.5, and I just showed how I would arrive at that if I were to actually use the coordinates along an x-axis, for example. When we're measuring segments, we want to make sure we're using the right terminology. So when we're talking about the lengths of segments, we would say that the lengths are, if they're equal, we would say the lengths are equal. So the lengths are equal. So this might be something like 5 equals 5, right? If the lengths are the same, I would say that the lengths of AB, segment AB and segment AD are equal. But if I'm just referring to them by name, so not referring specifically to the length, but just by name, I would say segment AB and segment AD are congruent. So length AB is equal to length AD, but segment AB is congruent with segment AD. So seems like splitting hairs sometimes, but it's really important that we're accurate with how we describe what we're seeing here. All right, so the easiest way usually is just to kind of jump into some examples and we can kind of see what we're talking about. So find which of the two segments are congruent. So segment XY, remember we're talking about a length, so no bar on top, and that's going to be equal to some number. So XY, I could use my formula, but this is pretty simple. I can just see that it's 1, 2, 3, 4 units. ZY is 1, 2, 3 units, and ZW is 1, 2, 3, 4 units. So I see both segments XY and ZW are equal to 4 units. So I can say that those segments are congruent. So from these calculations here, I know that XY, the segment XY, is congruent, right? An equal sign with a tilde, I guess, a little squiggly on top. So XY, segment XY is congruent with segment ZW. One thing that we'll see quite a lot of here as we move through this last half or 2/3 of the semester are postulates and theorems and proving theorems later on, something that we'll do in chapters 10 and 11, I want to say. But for right now, we're just going to start with some basic postulates. So segment addition postulate, and a postulate being something that we can accept without proof. It's kind of the building block of our theorems and proofs later. It's something that we just know is true, right? 1 + 1 is 2. We know that's true. So segment addition postulate is a basic one we're going to start with. And the segment addition postulate tells us if we have 3 points, A, B, and C, and they are collinear. So let's remember from the last unit when we looked at collinear, right? Co means things are shared and linear means a line. So if we have 3 points that are sharing a line and B is between A and C, that segment AB plus BC equals AC. So when I look at my diagram here, it's really maybe common sense, but if I have this segment AB and this segment BC, if I add those two things together, it'll give me section A, the length of segment AC. So seems kind of common sense, I guess, but it's something that we will utilize here and interject some algebra, and it makes it a little bit more challenging. So on the most simple level, I guess, if this was 4 units and this was 2 units, that's just telling me that if I add those two segments together, that the length of AC would be 6 units. So not too bad when we just have integers there, but when we introduce a little bit of algebra, it can get a little bit more challenging. So let's take a look at how this shakes out here. So we have segment AB is equal to, the length of AB is equal to 25. Find the value of x, then find the length of AN and NB. So this is, again, segment addition. I have 2 segments, AN. Let's do it in the same color that we... So I have segment AN and segment NB. And when I add them together, segment AB is equal to 25. So 2x plus 6. Again, I like to use parentheses because it helps me keep all of my signs straight. And this, I already messed one up. 2x minus 6 plus x plus 7. If I add AN plus NB together, it'll be equal to 25. So there I have applied the segment addition postulate. Now I'm just doing some basic algebra like we've done all along throughout the course of the year. So I'm going to combine like terms. These are the things I can combine. So my x's, I have a 2x plus 1x gives me 3x. Negative 6 plus 7 gives me plus 1. And I didn't do anything to the other side, so I still have a 25. And now I'm just trying to, again, find the value of x is the first thing I need to do. So 3x would equal 24, and x equals 8. So that's done. And then it asks me to find the length of AN. So I know AN equals 2x minus 6. And if x is 8, AN equals 2 times 8 is 16 minus 6. So AN equals 10. And the length of NB was equal to x plus 7. X was 8. Plus 7 is 15. 10 plus 15 is 25. So I confirm that they do add up to the total length. Example 3. In the diagram we have here, we have points A, B, C, D, and E, and they are all collinear. So I have 1, 2, 3, 4, 5 points that fall along the same line. And it's telling me that AE, so let's add some colors here. AE is 42. So the full length, well, the length of the segment from the two endpoints here is 42. CE is 10. And then it's telling me that BC, CD, and DE have equal lengths. So that means those segments are congruent. So BC, CD, and DE. So I've marked them with a single line. That's the general notation that we'll use to, oops, should make it look like two, but that's the way that we make it obvious that those are congruent, or mark that we know that they're congruent. And I know that means that the measurements are the same, tells me here. So if these two, CD and DE, are the same and together they add up to 10, then I know this section CD and DE have to each be 5. So I can go over here, CD equals 5, DE equals 5. I know BC is congruent to those, so the length of BC is also 5. AB, I need to determine the length of AB, so let me find a new color here. So AB, this segment right here, I know that AB plus BC plus CD plus DE, right? If I add up all of these smaller segments, that they will equal the total length, which is 42. And I know these last three are all 5. So 5, 5, and 5. So AB plus 15 is equal to 42. And if I subtract 15 from both sides, I know AB will be equal to 42 minus 15 is 27. So AB is 27. So AC, the length of segment AC, that would be 27 plus 5. From A to B and B to C, 27 plus 5, so a total of 32. And BE, from B to E, would be 5 plus 5 plus 5. For a total of 15. So there's a few steps involved with these, but it's not too bad, right? And we're almost there. Example 4, point S is between R and T on segment RT. So that means I have point R, point T, there's segment RT, and point S is between them. So we haven't talked about midpoint or the middle yet, but we want to make sure we understand between doesn't necessarily mean it's right in the middle. It's just somewhere in between. So I tried to purposely put it closer to one side so we don't think that it necessarily means that they're equal. So point S is between R and T. Use the given information to write an equation in terms of X. Solve the equation. So RS is equal to, let's do orange here. So RS is 3x minus 10, and ST is 4x minus 7, and RT, the whole thing, is equal to 60. So here I have two segments, RS and ST. Segment addition tells me if I add them together, it'll equal the whole thing. So 3x minus 10 plus 4x minus 7. So I'm going to use my parentheses just because it helps me, and with the colors, helps me really see what's going on. So I add those two segments together, and they are equal to 60. So now I need to combine my like terms. I have terms that have an x have an x, and then I have some constants here, so I need to gather those together. So 3x plus 4x is 7x. Negative 10 and negative 7 is negative 17 equals 60. To get this x term by itself, I need to add 17. That'll make it go away, and I always do everything equally, right? So that'll create 77 on this side. Those went away, and I'm left with 7x. And now to get the x all by itself, I divide by 7, and I do things equally to both sides. So I'm left with x equals 11. So that's important. I've done everything correct, I think, so far, but that's not the answer. It's asking me to find RS and ST. So RS was 3x minus 10, and the x is 11. So 3 times 11 minus 10. 3 times 11 is 33. 33 minus 10 is 23. So RS equals 23. And ST was 4x minus 7. X is still 11. 4 times 11, 44. 44 minus 7 is 37. So I found those two segments. And if I add those together, 23 plus 37, they come out to 60, which I see is the length I was given to begin with. So I confirm my answers. That's a good thing. And last one, the midpoint. The midpoint of a segment. So we talked a little bit on the previous problem. I kind of alluded to this. We said between, right? Between just means it's going to be somewhere along the line between the 2 points, but a midpoint means it's going to be right in the middle, and it's going to divide our segment into two congruent segments. So like we see in this section here, I have points AC in this line segment AC. Point B is right in the middle, and that means that the first portion from A to B and then from B to C are going to be equal lengths. So I can then say that the line segments are congruent. Right, so remember, I would say AB, the length of AB equals BC. But if I want to use them by name, I would say they are congruent. So the lengths are equal, the names are congruent. So example 5, M is the midpoint. So we're going to see a lot of these problems in the homework and on the quizzes later, and definitely on the exam. And it's a concept we really want to make sure that we are clear on. When I see something that tells me midpoint, make a note over here. Midpoint will generally mean that it will always mean that the segments are equal. So set them equal, right? We're going to generally see two types of problems. One like the one we did before, where we're going to use the segment addition postulate. We're going to add them up, and it'll equal the total length. Here, they do equal the total length also, but I don't know what the total length is. So kind of a hint, I guess, for the problems that we'll see. If you're given the total length, you're probably going to want to add them up and set them equal to the total length. If you're told there's a midpoint, you're probably going to want to set these two segments equal to each other, and that's how we'll solve. So in this case, we did one of the former where we added them up and set them equal to the full length using segment addition postulate. So this one, we'll use the midpoint. So M is the midpoint, so RM, the length of RM equals the length of MT. So 5x plus 9 equals 8x minus 36. And now I just want to get the x by itself. So again, there's multiple ways we could do it and places we could start. I always like to look for, get the x's together first. I know that the coefficient 8 is bigger on this side, so I'm going to subtract 5x. So that goes to 0, and then this is not going to create a negative number. And then I want to add 36. And that'll give me 45 on this side. Those canceled, and I'm left with 3x, and then all the way down at the bottom here. So if I divide both sides by 3, all right, x equals 15. So I'm able to solve for x, and then I can plug that back in to either one of these or both, depending on what it asks me to do. This one asked me to find the whole thing. So Rm, the length of Rm was 5x plus 9. X is 15, so 5 times 15 plus 9. 5 times 15, 5 times 10 is 50, plus 5 times 5 is 25. So 75 plus 9 is 84. And that was the length of Rm. Mt was 8x minus 36. X was 15. 8 times 10 is 80 plus 40, so 120 minus 36. So that would be 84. And I see that they are equal. That's a good thing, right? Because we used this concept that the midpoint cut them in half. So when I plug the x back in, I see that they're equal, so that worked out. And then it also asked me to find the full length of RT. So RT, if I used segment addition postulate, I can add those two things together. So 84 plus 84, so the full length would be 160 feet. So there's quite a few examples there, but I wanted to take my time and make sure that we saw a little bit of everything. So this covers everything we should need to do the homework, and also the problems that we'll see on the exam for this unit.